Hello, today we're going to do section 2.1, creating similar statements. The objectives of this section are to recognize and distinguish expressions and equations, determine whether an expression or equation is linear and give examples, and create an equivalent equation by applying an operation to both sides. Recall, an expression is a collection of numbers, variables, and operations together that represent a single value. Definition 1. When we write two algebraic expressions with an equal sign between them, this is called an equation. Solving an equation means finding all the numbers that make the equation true when substituted for the variable. A number that makes the equation true is called a solution of the equation. The collection of all values that make an equation true is called the solution set. Example 2. Determine if x equals 9 is a solution for each of the following equations. So to determine if a value is a solution, remember you need to substitute it in for the variable. So for this first one, 9 plus 3, does that equal 7? Well, no, it equals 12, not 7, so not a solution. Does 3 times 9 equal 7 times 9? Well, 3 times 9 is 27. 7 times 9 is 63. Those are not equal. So this is, again, not a solution. And finally, for 3x minus 7 equals 20, well, does 3 times 9 minus 7 equal 20? 3 times 9 is 27. 27 minus 7 is 20. That checks off. So this is a solution. Definition 3. Here we will focus on linear equations. A linear equation is an equation in which all the present variables lack exponents. For example, a linear equation can have terms like 4, 2x, negative 5y, anything where if there's a variable, it doesn't have an exponent. But it cannot have terms like x squared, square root of z, or 5y cubed. As we progress through the course, we will investigate strategies for solving some nonlinear equations, but this chapter will be on linear. Part 2. Equivalent equations. We create an equivalent equation by performing the same reversible operation to both sides of an equation, such as addition, subtraction, non-zero multiplication, or non-zero division. For multiplication and division, the reason why it has to be non-zero, well, for division, because we can't divide by 0, that's why it has to be non-zero. For multiplication, you can't multiply by 0 because that's not reversible, because when you multiply by 0, everything becomes 0. There's no way to get back to the original equation. In particular, equivalent equations have the same solution set. This important fact means that we can use the idea of equivalent equations to solve equations. More info in the next section. Example 4. Consider the following equations where r, w, y, and z are real numbers. So we have 3r equals 7, w plus 2 equals 9, and y minus 5 equals 7 plus z. And we just want to perform the following operations to both sides of each operation above to create equivalent equations. So for 3r equals 7, we want to add 7. So we indicate that by writing plus 7 underneath both sides. And we get 3r plus 7 equals 14. For the second one, again, I'm going to write plus 7 under both sides. Now, on the left-hand side, we do have like terms now, so that will become w plus 9 equals 16. And then for the third one, we're going to add 7 to both sides again. The negative 5 and 7 are like terms, so that becomes y plus 2. The 7 and 7 are like terms, so that becomes 14 plus z. Now, for part B, we want to now multiply both sides by 3. So 3r equals 7, multiplied by 3, multiplied by 3. We get 9r equals 21. And then I need to multiply this side by 3 and multiply this side by 3. Now this is where it gets interesting, because with this one, I'm multiplying w plus 2 by 3. Because of the distributive rule, that means this will become 3w plus 2, and you distribute that 3 in. So then we get 3w plus 6 equals 27. So notice if we look right above in part A, when we added 7, we didn't distribute the 7 because that's addition. We distribute when it's multiplication. So just keep that in mind. And y minus 5 equals 7 plus z, multiply by 3, multiply by 3. This time, instead of writing it with parentheses, I'm just going to distribute the 3 right away. So 3y minus 15 equals equals 21 plus 3z. Some final notes. Whatever you do, do it to both sides. Formally, the symbol double arrow is used to indicate that two equations are equivalent. For example, 3x plus 2 equals 90 is equivalent to 3x plus 9 equals 97, is equivalent to 3x plus 9 over 5 equals 97 over 5. In practice, we often omit this symbol. Instead, we arrange our work vertically with aligned equal signs to indicate the sequence of equations, like this, for example. So when I write them on top of each other like this, it means that they're equivalent equations. For clarity, we often include the operations like we did in the previous example. So for example, if we start with the 3x plus 2 equals 90, instead of going straight to 3x plus 9 equals 97, we'd write plus 7, and then usually a line to separate them. And then we would divide by 5 to get the final equation. And that is it for section 2.1.